Problem 5 on the test was exactly the same as problem set number 4. So this was the problem about chapter 4 on regression and correlation. So the first thing you were asked to do was to interpret the slope of the regression equation. So here's the regression equation right here. And we know that the number in front of the independent variable is the slope. So we know that the slope of this line is equal to negative 5.45. To interpret the slope, we have to go back to the definition of slope. And before we do that, let's get in mind what our variables are. So our x variable is your miles per gallon, and your y variable is your monthly cost. And so let's remember what the definition of slope is. The definition of slope is change in y, so that's change in monthly cost, over change in x, which is change in miles per gallon. And so we have a slope of negative 5.45, and it helps to interpret it if you put a 1 in the denominator. So to interpret the slope, it means to write a sentence that tells what this number represents. So what that says is that every time we change the miles per gallon by 1, in other words, every time we increase the miles per gallon by 1, the monthly cost tends to decrease because it's negative by $5.45. So let's write that down. Each increase in miles per gallon is associated with a decrease of about $5.45. You have to have words in your interpretation like is associated with or tends to. One mistake, if you got a -1 on your exam, it's because the sentence you wrote was too strong. You said something like it would always happen. So we have to make sure that we say that this is a tendency, that it will happen in general. There's an association, but not in a way that implies that that change always happens. Okay? So that's interpreting the slope. The next thing you were asked to do was interpret the y-intercept. So let's think about that for a second. It said interpret the y-intercept or explain why it would be inappropriate to do so. So let's take a look at how we would do that. So when we think about the y-intercept of a line, let's draw a picture of that so we can see what that looks like. So if you think about a line's y-intercept, it's where it crosses the y-axis. It's where the x-coordinate is 0 and your y-coordinate is the y-intercept. So in this case, the y-intercept is 348.91. Okay? So what that means is you have a car that gets 0 miles per gallon. But we know that there is no car that gets 0 miles per gallon, so it would be inappropriate to interpret the y-intercept because there is no car that gets 0 miles per gallon. C asked, is there a strong linear association between the two variables, y or y not? The way we measure a linear association is by using R, the correlation coefficient. So here we have an R value equal to negative 0.85, and that is a very strong association because it's close to -1. So the answer to this is yes. Why? Because you have an R value of negative 0.85. In part D, you were asked to find and interpret the coefficient of determination. So the coefficient of determination is R squared, and it's right here. So your R-squared value, and you may remember from the notes that we normally write this as a percentage, would be 72.8%. To interpret the coefficient of determination, that tells you how much of the variation in your y variable can be explained by your x variable. So in other words, 72.8% of the variation in monthly costs can be explained by the mileage that a car gets. All right, and number E asks us to use the regression equation if it was appropriate. So it said that in this data set, the data that we had, again, there was data, it went from x is equal to 14 to x is equal to 95. And you were asked, can we make a prediction for a mileage of 48? And the answer is yes. Why? Because it's within the scope of our data. So we could make a prediction for any value between 14 and 95. And the way you make the prediction is just by plugging in that value for miles per gallon into the regression equation and then solving for your monthly cost. Extrapolation is when one attempts to use the regression equation outside the scope of your data. So for a number out here or a number out here. Extrapolation should never be used. It's never a good idea to extrapolate, so we would not use the regression equation for any number greater than 95, and we should not use the regression equation for any number less than 14. So that problem was exactly like problem set number 4.